Hello, trust you're doing fantastic. In this video, I'm going to be taking you through the fundamentals of electrical quantities. The next concept I would like to talk about is the electrical energy. Now, the electrical energy is equal to power multiplied by time. If power is measured in watts and the time is seconds, then the unit of energy is watt seconds or joules. If the power is measured in kilowatts and the time in hours, then the unit of energy is kilowatt hours, often called the unit of electricity. Now, this is very important concept when we talk about the power consumption in our homes. How much electricity do we consume in our homes? What are the appliances that we use that consumes the electricity in our home? So with the concept of this course, it will guide you on how you can calculate the amount of electrical energy you consume in a week, in a month, and even in a year. So the electricity meter in our home records the number of kilowatt hours used, and it stores an energy meter. A 12-volt battery is connected across a load having a resistance of 40 ohms. The question says determine the current flowing in the load, the power consumed, and the energy dissipated in 2 minutes. First and foremost, we need to get the parameters. V equal to 12 volts. The resistance equal to 40 ohms. Now we need to calculate the current. For we to calculate the current, we say I equal to V over R, which is equal to 12 divided by 40. Now, if you do that calculation, you're going to get 0.3 amp. The next question says we should calculate the power consumed. Now, if we have to calculate the power consumed, it's going to be P equals to IV, because we have calculated for I and we know the value of V. So that would be 0.3 multiplied by 12. So that will give us 3.6 watts. Now the final question says we should calculate the energy. The energy dissipated, E, equal to power multiplied by time. In that case, it's going to be 3.6 multiplied by time. The time is 2 minutes. Remember I told you, whenever your unit is given in multiple or sub-multiple units, you have to convert it into the standard unit. So to convert this to standard unit in seconds, all you need to do is to say 2 multiplied by 60, which is 60 seconds, make 1 minute. So that will give us, when you multiply all this together, we're going to get 432 joules. Okay? This is what we're going to get. And then if you want to also write it this way, you can also say energy equal to 432 watt seconds. Okay, you can also write it this way, watt seconds. I think that's the only question we have. Alright, so we have another question that says, the source of EMF of 15 volts supplies a current of 2 amp for 6 minutes. How much energy is provided in this time? Alright, so the first thing we need to do is to know the parameters, okay? Voltage equal to 15 volt. I is equals to 2 amp. Now time is equals to 6 minutes. To calculate for the energy is equals to P multiplied by T. So what we need to look for, we need to look for P before we can calculate for energy. So in this case, we need to use the formula that says P is equals to V times I. Okay, so which is equal to 15 multiplied by 2. That will be 30 watts. So we can proceed to determine the energy, which is equals to 30 multiplied by 6 multiplied by 60. That will be 10,800 joules. Now you can also convert this to kilojoules. So you can say E equal to, for you to convert to kilojoules, all you just need to do is to divide by 1000. Then you have 10.8 kilojoules. Alright, so the next question says, electrical equipment in an office takes a current of 13 amp from a 240 volt supply. Estimate the cost per week of the electricity if the equipment is used for 30 hours each week, and 1 kilowatt hour of electricity costs 13.56 cents. Now don't forget that 100 cents equal to $1. Let's solve this problem. First, we need to know what the current is. Now current equal to 13 amp. The voltage equal to 240 V. Alright? And then we have the time equal to 30 hours. Now 1 kilowatt hour equal to 13.56 cents. Now remember that power P equal to IV, which is equal to I is 13 multiplied by V 240. Okay, so that will give us power equal to 3120 watts. Now which is also equal to 3.12 kilowatts. Energy is equal to power multiplied by T, which is 3.12 multiplied by 30 hours. Since we're working in hours, it means that the SI unit we're working with is the kilowatt hour. So this will give us, when you multiply this, you're going to get 93.6 kilowatt hour. Okay, so now if 1 kilowatt hour equal to 13.56 cents, then 93.6 kilowatt hour equal to X cents. Now if you make X the subject of formula, what we'll get at the end of the day, it will be X equal to 93.6 multiplied by 13.56 divided by 1. Okay, so at the end of the day we're going to have X equal to 1269.216 cents. This is what we're going to get at the end of the day. So for the cost, therefore, the cost for using the equipment for 30 hours per week is 1269.216 cents. Now, when you convert cent to dollar, we're going to get, when you divide by 100, we're going to get 12.69. So it's going to cost $12.69 per week. Okay? So this is the answer. It's going to cost $12.69 per week. That will be the cost of using the equipment 30 hours per week. All right then, enjoy the cost. Bye.